Welcome, ladies and gentlemen. Today I'm going to be teaching you about multiple representations of a linear function. And you should already know what these terms function and linear mean from previous videos. Remember, a function is just a relationship between two variables, and a linear function is going to be a function that creates a straight line. And it says here a linear function can be represented multiple ways. One of the ways we can represent a function is with a table, and we have represented functions with tables in previous videos. We've also represented them on the coordinate plane, and when I'm talking about on a coordinate plane right here, I'm referring to the graphs that we have been creating. We can also represent a linear function as an equation, and that's what's going to be kind of new for us today, and as a real-world situation. And we're mainly going to focus on these bottom two right here, because these are going to be the new material that's focused on in this video, as opposed to these two, which we talked about in previous videos. Okay, so we're going to start out with some examples, and I want you to notice that I have a description, I have a verbal description of the problem, but what I don't have is an equation, a graph, or a table that's completed. So I am going to have to derive an equation, a graph, and a table all from this description. Okay, so I'm going to give you one out of the four, and you're going to have to create the other three using that one. So it says at the Parks Mall it costs $5 to enter the garage, and that's missing a letter there, garage, plus $2 for every hour the car is parked. Okay, so since we're comfortable with tables and graphs, we're going to go ahead and start by generating our table of values and by creating our graph. Okay, and they were very nice to us because they told us our input is going to be hours, that's our independent variable. Our output is the total charge, and that's going to be our dependent variable. And if you think about it, it makes sense because your total charge is going to depend on how many hours you're parked in the garage. Okay, so let's think about this situation. I enter the garage and I'm parked for 0 hours. So maybe I just run in and grab something real quick. It's still going to cost me $5 to enter the garage, but I was there for 0 hours, so I don't have to pay any of this fee here. Now, if I'm there for 1 hour, I'm going to have to pay $5 to enter the garage plus 2 times 1 hour, since I was there for 1 hour. So that's going to be a total of $7. If I'm there for 2 hours, it's going to be 5 plus 2 times 2, which is 9. And if I'm there for 3, it's going to be 5 plus 2 times 3 hours, which gets me a total of 11. So if you notice, now I have, from the table, I have a list of ordered pairs. And I'm going to go ahead and write those ordered pairs off to the side. The first ordered pair is 0, 5. Remember, whenever we list an ordered pair, it's always the X, then the Y. The next ordered pair is 1, 7. And then we have 2, 9. And then we have 3, 11. Okay, so we created our table of values based on the description. And now I'm going to create a graph. Okay, first thing I need to do is give myself some numbers here on the X and Y axis. And I'm just going to go ahead and number out to 5. And here on my vertical axis, I'm going to number up to 11, since that looks like the biggest number I have there. Okay. Let me just fill this in with the numbers, and I'll be ready to graph. Okay, so let's look at our first point. 0, 5. So for 0 hours, it cost me $5. So I'm going to represent that on the graph with an ordered pair at 0, 5. So over 0, side to side 0, up 5. So what that shows me on the graph is that for 0 hours, I paid $5. My next ordered pair is 1, 7. So I'm going to go over 1, up 7. That ordered pair is showing me the cost for 1 hour. It's going to cost me $7. I'm going to go ahead and finish plotting the rest of my ordered pairs, 2, 9, and 3, 11. Now remember, these are linear, so they should form a straight line. I'm going to go ahead and connect those points as best I can, trying to make a straight line. Okay, so I have represented my verbal description with a table of values and a graph. The last thing I need to do is write an equation. Again, this is the part that's going to be pretty new for us. We're always going to start our equations with y equals, okay? Our dependent variable, we're going to set that equal to everything else, okay? Because this is what's going to depend on everything else. Okay, so let's look back at the situation. $5 to enter. That's what we call a constant. No matter what, I have to pay that $5 fee. So I'm not going to attach that 5 to any variable or anything. It's just a 5 in my equation. Now, I also have to pay $2 for every hour, $2 for every hour. Well, hours are being represented with the variable x. So I'm going to be adding 2x to the end of my equation. So it's $5, that's a constant, plus 2 times every hour. And if you notice, this part right here is what I was doing over here when I was trying to find, right here, when I was trying to find my y values. I was doing 5 plus 2 times 0, 5 plus 2 times 1, 5 plus 2 times 2. So notice all of these pieces here are going to be interconnected. Okay, we're going to try one more together. Notice this one, I gave you the equation. We're going to have to create a description, a graph, and a table. Okay, so let's go equation to the table. I usually feel most comfortable starting with the table. So I'm going to plug in a 0, 10 cents, 0.10. I'm assuming that's money, I don't know. 0.10 times 0 plus 50. So that's just going to be 50. And then 0.10 times 100 plus 50 is going to get me, that's going to be 10 plus 50, so 60. 0.10 times 200 plus 50 is going to get me 20 plus 50, which is 70. And I'm just going to finish this out. That's going to be 30 plus 50, which gets me 80. And that's going to be 90. Okay, so now that I have my table of values, I'm going to go ahead and create my ordered pairs. So my ordered pairs, again, putting the x with the y, 0, 50, 100, 60, 200, 70, 380, and 490. Okay, so now I'm going to go ahead and create my graph. You look at my x values. They go all the way from 0 to 400. So what I'm going to do is I'm going to count up by 100s just to make this a little bit faster. It's going to be 100, 200, 300, 400. And then if you look at my y values, they go from 50 all the way to 90. So I'm going to count up by 10s. Try to make these equally spaced. I know sometimes that's difficult, especially for me. And as I got to the top there, I had to kind of cram them together a little bit. Okay, so my first ordered pair is 0, 50. Okay, so what that means is, well, actually we're not quite sure. We don't have a description yet, but we know that when the x value is 0, our y value is 50. When our x value is 100, our y value is 60. And then we have 270, 380, and 490. I want you to notice both graphs that we did today, they only had the upper right-hand quadrant in them because it only made sense to have positive ordered pairs in these situations. That's why we only gave you that section of the graph. Okay, so now we have our table, we have our graph. We started with our equation, so the last thing is we need to write a description. Now, our descriptions are going to vary. But there are some things that should be the same across the board. You should have in your description that the 50 is a constant. It's not going to change no matter what. The 10 cents is what you'd have to multiply by your X value. Okay, and we haven't determined what that X value is. We know that everything here, the Y value, is the cost. So let me go ahead and put that over here, the cost. What could the cost be dependent on? Cost could be dependent on, let's say, hours. Okay, again, these are going to vary a little bit. So if X is the hours, it would be 10 cents per hour plus $50. Now, what is this situation going to be? That's up to you. I'm going to say my monthly cell phone bill has a fixed fee, that's my constant, of $50 plus it costs 10 cents for each hour of talking. Okay, again, the situations, the descriptions are going to vary. Okay, so now the last thing we need for you guys to do, this is you're on your own. Marissa wants to go to Space Camp. The application is non-refundable and is $45, and the cost of camp is $125 per day. So what we want you to do is create an equation, create a table, and create a graph.